So I'm continuing my experimenting and evolution of what my next PCB might look like, or PCBs for my 386DX slash 486DLC slash something other. So previously I've talked about this large board that I have running. It's a pair of PCBs that connect together, and that's got my 386DX and 486DLC running, and that is working. But I've kind of wanted to go back, and this was a large 2-layer board. I was hoping to maybe add interplanes for ground in VCC, add some better inline termination, and just other cleanup of the system. And through that, I've gone through a series of videos where I've been just experimenting. Maybe I go to a type of a card that plugs into a backplane and has my processor, coprocessor, main functionality, and this still had a lot of through hole. I then went to some more surface mount. I then eventually got rid of the PSOC, these prototype boards, and put the PSOCs directly on this card itself. And then from there, I maybe thought, well, what about breaking it out even further? And that's a version where I had kind of a backplane and a card for the processor and decode and ROM, RAM, shadow, and I/O. Now, pros and cons to all of these, but the things I've been trying to work through is just overall risk of the design and how likely it is I'm going to get it right or not right and have to rework and reorder and do a lot of troubleshooting. So with a smaller modular design like this, if I have some sort of a mistake in one of these cards, I can order just that card. Or if I want to change the functionality in a card, I can order just that piece and not have to order the whole thing. Versus in one of these, maybe it is a smaller overall board and I don't have a lot of edge connections or interboard type of connections between PCBs on a backplane. And so there's definitely some pros to that. And so I've continued to experiment, and one of the things that I want to do is consolidate. Instead of having 3 PSOCs, this version here, you see there's 1, 2, 3 of them. Even though they're right on the PCB, it still adds a lot of routing complexity. So I'm experimenting. I've ordered up just a little test board to play with a larger PSOC that hopefully will allow me to consolidate all 3 of those others into one here. But I've been looking at the design and saying, well, how else can I further, I'm going to say make this simpler for routing so I don't have to go with an 8-layer or higher board because they're not affordable for me. How do I simplify the routing? How do I get the interplanes for ground and VCC? How do I get some of my termination? All this stuff that I've added in here, but do it in a way that maybe balances the nicety of a single board instead of all these modular boards, and isn't crazy expensive. I don't want to spend $150 for a set of boards if I can help it. So that's maybe gotten me to this update. And this is the board I now have laid out. And I'll talk about this in a minute as far as the routing is concerned. So I'll come back to that. But let me just talk about the general features of this board for a moment. If I zoom into this and just kind of work my way up to the top, basics like power coming in. I really like banana connectors, and I have a benchtop power supply that I use, and I'm going to continue to use for this type of stuff. Maybe somewhere down the road, if I really do get a cleaned up overall system, I'll change that power setup. But this is what I'm doing for now. I'm bringing power in through banana connectors, and that's convenient for me. You're going to notice a big thing here, though, that my processor has changed. So I've gone from a 386DX or a 486DLC to a 486DX2. So this is a larger processor, and so it takes up more space on this. But a benefit is it has the coprocessor built in. So when I go back to this other web page, just my blog post where I've been tracking some of this, I can get rid of this entire socket for the coprocessor because it's built into the main processor. And actually, this main processor being a bit larger, it's kind of nice because it actually spreads out all those pins a bit more. And maybe there's more pins, but it seems like they're easier to route because this processor is larger. There's more space in the middle for other things, capacitors, whatever I need to be putting in there. You'll also notice on this that I did pull out all of the PSOCs, the 3 individual PSOCs, and I have a single consolidated PSOC. Plus, I pulled out my 2 different ICs for this PAL1 and PAL2. These 2 chips, which is kind of the Intel logic for a bunch of the signals on the board, timing signals, things like that. I'm going to actually put those right into, or attempt to put those right into the same single PSOC. So I've taken 3 PSOCs plus 2 PALs and consolidated them down into this PSOC. And I believe I have everything already connected. So I have all the actual lines run to make this work. And I have some free pins. So after I've gone through and really cleaned things up and taken out stuff that really I didn't need for inputs, outputs, I've got some spare capacity yet on this as far as I/O pins, which is great. Question, of course, will be, can I now program everything in it to do all the things that the 2 PAL chips were doing plus the other 3 PSOCs? I believe I will be able to, but that is to be tested, and I'm going to do some of that testing on one of these little boards like this before I get too far. I'm not going to order, of course, a new PCB until I validated that I think this can do everything I'm hoping it can do. But getting rid of the 2 PALs, getting rid of the 3 PSOCs, getting rid of the coprocessor really freed up a lot of space on this board. And I'm finding that this larger PSOC is actually easier to route than the smaller PSOC, just because it gives me a lot of room underneath for the capacitors. You'll just see that they're nicely laid out right inside the footprint of that. So that all has turned out quite nicely. So that's a nice win. So I've got my processor, I've got this single PSOC, I've got my ROM, I've got a socket for an oscillator so that I can run any clock speed and not be limited to whatever this PSOC supports within it. I've got my interrupt controller, I've got all my SPI support with this VIA. I have a pair of control latches, one over here and another one over here. And then you're going to see a lot more data transceivers. So let me maybe walk through the rest of these data transceivers in a second. Up here I do have clock distribution chips. So one of these will distribute the high-speed clock 2, which I'm still calling it clock 2, CLK2, and then another one is clock, CLK. And then I've got some chips over here. These 5 chips all have to do with my shadowing process. So when the system initializes, this PSOC will copy all of the ROM into these RAM chips off to the right. And to do that, I need some transceivers to really duplicate the lowest byte of data to the other 3 bytes. And so that way, the way I have this logic working, it can get the right data to the right chip. But I also had a bunch of pins previously on my shadow PSOC that were writing to addresses A30 down to A17, really just fixed values, because these RAM chips don't need those high of address lines. And so what I did, instead of having the PSOC generate all of those, I just created basically some latches here. And these latches allow me to latch in values and put them out on the address bus for these pins A30 down to A17, or most of the signals from A30 to A17, either pulling them low or high as they need to be set to do my shadowing. So then that leaves, I mentioned the RAM here, that leaves all of these address latches. And well, I've got 4 address latches and all these data transceivers. So these address latches up here are what you would expect, standard latches to latch the addressing coming off of my 486 here. And I do have an inline resistor for all of those. Probably don't need it on all of the signals, but I'm putting the option there. And if anything, I'll put a 0 ohm resistor if I don't need them. But maybe the lowest address lines, 0, 1, 2, 3, I probably need some inline resistors because those are moving faster. But I have the option there for inline resistors. And then all these data transceivers, I've got the normal 4 data transceivers I've had this entire time, but then I had to add 3 more to support 8-bit transfers and another pair to support 16-bit transfers. So on the 386DX and the 486DLC, I didn't have to do byte swapping, but with the 486DX, you have to do byte swapping as I understand it. And so really these are going to be, all of these will be controlled by this PSOC, when they are enabled. So if I'm doing a 32-bit I/O transfer as an example, it'll use these 4 data transceivers. If I do an 8-bit I/O, it's going to use basically these, one of these 8-bit transceivers here. And if I do a 16-bit, it's going to use these transceivers over here. Then I continue down and I put in some ISA slots, and this actually should leave me room. I probably could squeeze in one more ISA slot, maybe two. Let's see, 1, 2, 3, 4, 5. I have 6 of them here. I think I can fit up to 8, but I'm not going to worry about that for now. This is plenty. And then I added in a PCI slot basically as an extension. So that will give me this extension of 32-bit addressing and 32-bit data and some other like SPI signals, things like that, that I want to use. And I'm going to just place those in these custom extensions. And so what I think I would end up doing then is, as I get into this, I'll probably have my VGA card as it is. That's just a plain old ISA card. Then I'm going to have an I/O card, and that I/O card is probably going to use this full length. And so wherever I place it, maybe the video card goes up top, I'll put the I/O card right here. And that I/O card will do keyboard, mouse, my communication back to my PC for serial debugging. Basically all of my SPI functionality will kind of get, well, a lot of the SPI functionality for I/O. This via up here will do the raw SPI functionality. I'll get the appropriate signals brought down into this connector, and then that will let me do my keyboard, my mouse, communication to the PC, etc. I probably will also put the IDE interface on that same card and just kind of treat it as one, a master I/O card for this system. And I think that'll all work fine. There aren't any crazy high-speed things that I'll need on this slot. The IDE, maybe it's the thing I would access at the fastest speed, but we'll see. I'll work on building that out. I don't think that card is going to be a big deal. I think that's going to be manageable. And then I'll have room for a sound card or whatever else I want to put in here. And so this layout, the way I have it, if I go over to the design for a second, is about 10 inches by 10.5 inches. So it isn't crazy big. This will fit in an ATX case. And basically, it's maybe slightly over ATX, but it's pretty darn close. It'll fit. I believe I have these standoff placements in the correct location. The top ones probably aren't quite yet. But I'll have to get all the rest of the placements in here. So that'll cause a few changes in this design as I go. And I know with the auto routing, there's a lot of bad things I see here. There's things that are too close to the edge. I'll have to put in some no routing zones to make sure I don't get things into the edge. Or if I'm entirely manually routing it, of course, I'll stay away from that edge. But interestingly, I was able to get this fully routed on 4 layers. So this is currently a 4-layer setup. I've got top signal, bottom signal, and then my ground and VCC planes. And that is fully routed. I don't think I have anything left unrouted in this. Full DRC check passes, other than I've got some warnings if I'm too close to the edge, which I am. Like this trace right here is crazy close. So I'll fix that as I move forward. But I have, I think, everything routed to this PSOC here that I need to have routed for control signals. What I have not routed yet is any of the via SPI functionality to get these SPI lines down to different pins on these custom extensions. So I'll have to get some, maybe a handful. I don't need all of these SPI lines coming down, but enough down here to get my keyboard, mouse, PC communication, etc. But that's, half a dozen signals. That's not a lot that I'll just have to get from over here to over here. I see plenty of, I think, space where I can bring that in, for example, even right along here. So we'll see what that looks like. I need to go back and read that Intel hardware reference guide, this one right here, from top to bottom. So in the next couple of weeks, I've got some time off for the holidays, and I think I'm going to just use some of that to read through this book specifically from top to bottom and just see what else am I missing. There's a lot of functionality that they'll put into PLDs, and the back of this book does have, all the code for that PLD. So I need to run through that PLD code. Most of it, if not all of it, it seems like is for dynamic RAM or DRAM timing, which I am not doing any of that. I'm going to stick with my static RAM for now. At some point, I need to learn how to deal with DRAM, but that for now is not something I'm taking on, and so that'll be a later thing for me to add, along with DMA. You'll notice I have a little comment here. There's no DMA support on here, no DRAM support, and I'm not going to leverage any of the cache functionality, I don't think, on this processor. So that cache functionality gets enabled basically through the BIOS code that I would have, and I just won't be enabling it to start. I'll have to learn more about that and see how that fits into how I have RAM set up. I'm only going to have 2 meg of RAM here, minus whatever I take out for BIOS shadowing and other I/O address spaces. So I don't have a lot of RAM to work with, but it's enough that I can be working with FreeDOS or maybe something beyond FreeDOS that could leverage that 1 meg to 2 meg address space. And maybe later, if I want, I could add a RAM card into this. I've done previous designs with RAM cards, so I think that is definitely something I could do, but that is a bridge to cross at a later date. But if I, get into this document here, a lot of good stuff in here. Of course, getting in through all of the different signals and making sure I understand those, make sure I'm not missing any. There are quite a few new signals on this processor compared to the 486DLC, and a lot of them are signals I'm not going to be using, either cache related or there must be a management interface of some sort that I don't intend to really take advantage of. And like all this external cache support, for now, I'm going to just have to go without that until I can get the core system working, and then maybe come back with a later design. Now, if I do search in here for, I think, byte swap, there is some information on that just to show you what that kind of starts to look like. And so they get into this here, that if you're going to do, for example, 8-bit, you've got these 3 extra buffers, and I believe this is a typo. That should be 4, 5, 6. They have a 3 here. But 3 additional buffers that I need, or transceivers, to support 8-bit devices, and then they do something similar when I come in here for 16-bit devices. So those are 2 additional buffers that I've got to have. So that's what you see, is I've got these 3 plus those 2, and that's these 5 over here, as I understand it right now. But there's so much here. If I look at how many pages are in this, this is a long document, 483 pages up here, that I need to just read through and see if there are other things that are quite different than what I've seen before. And they do have some schematics in the back, and those schematics are all assuming that I'm running DRAM, which I'm not. So I'll have to see if I can filter through that too and see how much of this content is helpful for my design. Is there something I catch that would be good to change in my setup? And if I go back to my design for a second, I can go over to my PSOC. And after I went through, I spent some time looking at the PAL 1 and PAL 2 and my other 3 PSOCs, and there was a bunch of interconnectivity between those 5 chips. So 3 PSOCs, 2 PAL chips. And by the time I got rid of all the interconnectivity lines, because it's all now in one PSOC would be the goal, it ends up that I have some free lines. And so you can see that, I've tried to get this all connected up so that I can program it right on the board, just plug in my little USB to header here and program these. But if I look through this, here I've got 2 free pins. Here I have another few pins. So that's 5 that I'm not using. It looks like one up here, 6, 7, 8. So I think I have 8 more pins that I could be leveraging in the PSOC. So as I'm reading up on this processor, if I'm missing some other signals, I can probably get those added in here, or maybe there's even other logic on here. If I have a simple little, like this right here, this simple little logic chip, I could probably incorporate that into the PSOC if I thought that made sense to do. And this is just a simple little 7402, which you can't see with that chip there, but so just an 02 here that I could easily, and I don't think I'm really even doing much on it, so that could easily get incorporated into the PSOC if that seems to make sense. But that's good that I ended up with some free pins there to do some further work. And I've gone through and I'm reading through the day sheet for this specific PSOC, trying to just triple check that I have things laid out properly. And that little design test card, this one right here, will let me test, if what I understand of this PSOC and this layout works. I should be able to test that on this specific prototype board. So far, that seems like it's all moving in the right direction. So, I've got this layout. Like I said, this is fully routed, no DRC errors other than I got some lines too close to the edge of the board. So I have it set up to warn me about that. If I get through the reading more on the PSOC and then on the 46DX, and I think I have a chance of making this PSOC control all that different glue logic, I might try to get something like this ordered up. But the next step would be for me to delete all the routing and walk through this as much as I can by hand. Maybe if I can get all the most important signals routed by hand, then I can let it run some of the other ones through the auto router. But we'll see. I know there are a lot of traces on this, so it's going to be quite the effort to route this. So that might be a good holiday break type of activity, and I imagine that's going to take me a week or two at least, if not longer. And then I'll post that, and I imagine there'll be a lot of good ideas and feedback on how to further improve it as I'm going through that. But I think that's about it. Maybe one other comment I did for all my, both for address and data lines, I do have pull up or pull downs down here. I don't think for my address lines I'll need that. I have the inlines, but we'll see. And then for the data lines, I'll likely use pull up or pull down, or maybe even put in another set to make it a Thevenin so I can do a pull up and pull down. That would be easy to add to this. And then I have to also decide, do I have for all of my data lines, should I have on the other side of all the data lines also terminate? So terminate on both sides of the data lines. We'll see. More for me to play around with there. And back in this post over here, I am trying to capture, I'll zoom out a little bit here, kind of what is my current plan and suggestions I've been getting, and just things that I need to go back for PCB design considerations and further read through that and add to that. And then I still have all of this IC selection to do. And I think the last I had commented on this was AHCT maybe is what I'll end up going with. But we'll see. I still have work to do on that. Definitely curious if you have thoughts on this. Anything that, for those of you that have done 486DX work, especially compared to the 386DX, any big gotchas when you make that jump? It seems like cache control is the big thing, and byte swapping was another thing. I know there's a lot I don't know yet about the 486DX, DX2, DX4, whatever one I go with, but I've ordered up some 5-volt. I think I have 2 5-volt DX2s, one in hand and another one coming just in case I have problems with one of them. But let me know. I appreciate it. Thanks.